Hello, today we'll talk about polygons and their interior angles. So let's get started. After this lesson, you should be able to define a polygon by giving its characteristics. While exploring different types of polygon, you should be able to analyze the relationship between number of sides and sum of angles. Lastly, you should be able to come up with a formula that can be used to find the sum of angles in many-sided polygon. You may have seen simple polygons such as triangles, rectangles, trapezoids, and pentagon in previous math classes. For a geometric shape to be a polygon, it has to have certain characteristics. Firstly, polygons are made by straight lines. Secondly, polygons are enclosed shapes. And lastly, polygons are flat shapes, which means that they are in two dimensions. Polygons are all around us. They are broadly used in architecture such as in buildings and sculpture. We also see polygons in nature. For example, honeycombs are in the hexagonal shape. Sunflowers are in pentagonal shape. Interestingly, giraffe's prints on its skin are in irregular pentagonal shapes. As we said earlier, polygons are two-dimensional enclosed shapes made by straight lines, as in visuals on the left side of the screen. Non-polygons are shapes that doesn't satisfy the above-mentioned characteristics. For example, a half moon is not a polygon because it's made by curved line. Brackets look like a polygon, however, it's not a closed shape, therefore it's not a polygon. Lastly, semicircular rectangle is not a polygon because one end is made by curved line. If you want to check your understanding of polygons, click or copy-paste the link below and play the interactive game. The web page should look like this. Now let's explore some polygons. As I navigate and show you different polygons, I want you to record the number of sides, sum of angles, and number of triangles that we can fit in any polygons. So here we have a triangle. Each side and angles are in equal measurements, but you can drag one vertex and change that triangle in other different types. However, the only thing that is not being changed is the sum of angles, which is 180 degrees. Now let's take a look at quadrilaterals, which are four-sided shapes. So here we have a regular quadrilateral, meaning that all four sides and all four angles are in the same measurement, and the sum of interior angles add up to 360 degrees. Again, we can change this regular polygon by dragging and moving one vertex to any place. Again, the sum of interior angles is staying the same, being 360 degrees. Let's take a look at pentagon with 5 sides. The sum of interior angles is 540 degrees. Next, we have a hexagon with 6 sides. The sum of angles add up to 720 degrees. Again, we can change that regular hexagon to irregular hexagon by moving the vertex to any place. As you can see, as I move and drag the vertex, the only thing that is not being changed is the sum of angles. Next, we have a heptagon, a 7-sided polygon. The sum of angles add up to 900 degrees. And lastly, we have an octagon with 8 sides, and the sum of interior angles is 1080 degrees. As I use the angle sum tool, you should have the following records. The number of sides in a triangle is 3. How many triangles can we fit in a triangle? Obviously, just one, which is itself. And the sum of all angles add up to 180 degrees. For quadrilaterals, such as rectangles, squares, kites, rhombus, the number of sides is 4. If we draw one diagonal from one corner to the opposite, we can fit 2 triangles, and the sum of all angles is 360 degrees. For pentagons, number of sides is 5. we can fit 3 triangles. The interior angles add up to 540 degrees. At this point, some of you can see the pattern in the numbers and expect what is next. One can just draw the polygon and triangulate it to see how many triangles can fit in. However, drawing method can be time-consuming and hard when number of sides are more than 8 or 10. Therefore, let's come up with a formula that can be used to find the sum of interior angles for any given polygon. Take a look at number of sides and number of triangles row. Have you noticed any relationship? What is the difference between number of sides and number of triangles? As you can see, every time the number of sides were reduced by 2 to get the number of triangles. Then if we have n-sided polygon, then the number of triangles will be n minus 2. Remember, triangle's angle sum is 180 degrees. So if we multiply n minus 2 by 180 degrees, we can get the sum of interior angles for n-sided polygon. So now we can finalize and formulate the formula for the sum of interior angles that can be used for any given polygons with any sides. Keep this formula in mind because you will be using it in your practice. Let's do this example together. We need to find the sum of interior angles of a 25-sided polygon. There are 25 sides, therefore n is equals to 25. Remember the formula, it's 180 times n minus 2. If we do the substitution for n being 25, we'll get 180 times the difference of 25 and 2. The result is 4,140 degrees, which is the sum of all angles in that polygon. Now it's time for your independent practice. Read all 3 questions and find the sum of interior angles. Match the question with the result.